this curve crosses the y-axis at two different points, and it crosses the x-axis at one point. You need to work out the value of a given that it crosses the x-axis at minus 4, 0. So how do you think you would go about doing this? You take that coordinate, minus 4, 0, and you can write it as x equals minus 4 and y equals 0. You have a parametric, so that means minus 4 equals at squared plus t, and 0 equals a bracket t cubed plus 8. And now what you've got is a simultaneous equation. Okay? Can you try and solve this for me, please? So if you try and solve equation 2 first, by dividing a, you would get this. And now you take the 8 to the other side, it should be cubed. And now the cube root of minus 8 is minus 2. Okay. So at the point minus 4, 0, t equals minus 2. You can then plug that into equation 1. Like this, which would give you minus 4 equals 4a minus 2, minus 2 equals 4a, a equals minus a half. There you go. You've worked out the value of a. Okay, find the coordinates of the points A and B where the curve crosses the y-axis. Yeah? If it crosses the y-axis, what is the value of x? 0. So you can take equation 1, 0 equals minus a half t squared plus t. I'm plugging in my value of a, which I worked out in part A. I'm plugging in x equals 0 because I know it's crossing the y-axis. And now, by working out t, you can essentially work out the 2 points where it crosses, or it can help you to do that. So, to work out t, you can factorize. Like this. So that means t equals 0 and minus a half t plus 1 equals 0. So t equals 2. You can work out the y coordinate when t equals 0 because you already know x is 0. So when t equals 0, what does y equal? Minus 4. And then when t equals 2, what does y equal? Minus 8. So your coordinates are 0 minus 4, that would be A, and 0 minus 8, that would be B. There you go. That's that one done. Okay. Have a look at this one. Can you try this one on your own, please? Okay. It says, find the point where the curve intersects the line y equals pi squared. So you take your y parametric, you make that equal to pi squared. And now you can solve for t. By square rooting, pi squared, you end up with plus minus pi. Okay? Then you take this pi over 6 to the other side, you add it, so you can have two solutions. Pi plus pi over 6 or minus pi plus pi over 6. So you've got 7 pi over 6 and minus 5 pi over 6. Those are your two solutions. Now, in your range, it tells you that t can't be less than minus pi over 2. So you can reject this one and you accept this as your only value. Okay, now it says find the point. Yeah, so find the coordinate. You've got the y coordinate. You've got y equals pi squared. You now need to work out x. That was the whole point of getting t first. Because now you can plug 7 pi over 2 into, 7 pi over 6 into the x parametric. And then when you simplify that, you get minus 1 plus root 3 all over 2. So your coordinates, or your coordinate, that should be a 3, and pi squared. That's where your parametric, your curve, crosses y equals pi squared. Okay, part B. Find the coordinates of the points A and B where the curve cuts the y-axis. Same as the other one. If it cuts the y-axis, x is equal to 0. So you try and work out the values of t when x equals 0. Cos t plus sine t equals 0. So that means sine t equals minus cos t. So sine t is the same as minus 1 times cos t. So now you can divide by cos to give you tan. Okay, so tan therefore has two values. T has two values, minus pi over 4 or 3 pi over 4. That's after doing the cast diagram. Now, the range of values for t is minus pi over 2 to 4 pi over 3, which means both of these values are accepted. Okay, we know the x-coordinate is 0. So now we can work out the y-coordinate by substituting in t. So minus pi over 4 minus pi over 6 all squared, and then 3 pi over 4 minus pi over 6 all squared. This gives 25 pi squared over 144. This gives 49 pi squared over 144. And those are your two coordinates. 0, 25 pi squared over 144. That's A. And 0, 49 pi squared over 144. That's B. There you go. That is points of intersection.